There's a reason some scientists stay silent when certain quantum results come up. It's not because the results are weak or unverified. Quite the opposite. They're proven again and again. The silence comes from discomfort, from the fact that the data hints at something almost impossible to explain in the language of ordinary science. Experiments suggest that reality itself may not exist in a definite way until it is observed. Some results go further, hinting that awareness, your very consciousness, could play a role in shaping the world around you. And the more evidence that accumulates, the more unsettling the conclusion becomes. What we call reality may not actually be real until you, the observer, engage with it. In this video, we're stepping into one of the most controversial, fascinating, and downright disorienting ideas in all of science. The possibility that observation doesn't just reveal reality, but participates in creating it. We'll explore the experiments that expose this mystery, the theories that attempt to explain it, the paradoxes that remain unsolved, and why even the most respected physicists struggle to agree on what it truly means. By the end, you may not just understand the physics, you may begin to see your own perception, your thoughts, and your attention as far more powerful than you ever imagined. Because once you grasp how reality responds to observation, you may begin to observe yourself differently too. There are truths so bizarre that most people stop noticing them, like the fact that nothing you see or touch is actually solid, or that the very moment you look at something, its state changes, not metaphorically, but literally. The reality you assume is steady and predictable may actually be just one version of many, waiting to be called into existence by your attention. That isn't mystical philosophy. That's experimental physics. Picture this. You walk into a room where every object is hidden under silk cloth. You can make guesses about what's underneath: a table, a lamp, some unrecognizable shape in the corner. But until you pull away the covering, each item remains undefined, as though it could be several things at once. It's like a story that holds countless possible endings, each one waiting to be chosen. This is not just poetic imagery. This is astonishingly close to how the quantum world actually functions. And it's not an abstract curiosity, it's reality. And it's far stranger and far more unsettling than we were ever taught to believe. At the smallest scales we've ever investigated, where atoms break down into components even less tangible, the world begins to behave like a trickster. The predictable rules you memorized in school stop applying. Particles, a word that turns out to be deeply misleading, no longer behave like solid marbles. They act like waves, like clouds of probability, like a menu of possibilities. An electron, for instance, doesn't carry a definite location or a clear momentum. Before measurement, it doesn't simply hide its position from us. It has no position at all. It exists as a smear of possibilities, everywhere it could be, all at once. Then, the instant we observe it, the haze collapses into one location, as though the particle decided it had always been there. This sudden collapse, the snapping of possibility into certainty, is one of the most disturbing truths of quantum physics. It implies that reality is not a stage set that exists on its own, passively awaiting discovery. Instead, it may need the observer, an act of awareness, to become definite. Scientists have tested this repeatedly, and the strangest results keep pointing in the same direction. The most famous demonstration is the double slit experiment. When researchers fired particles such as photons or electrons toward a barrier with two openings, the expectation was simple. Each particle should behave like a bullet, passing through one slit or the other. But that isn't what happened. When no one measured which slit the particle passed through, the particles acted like waves, interfering with themselves, as if they had traveled through both slits at the same time. Yet the moment scientists placed detectors to check the path, the wave behavior disappeared. The particles behaved like little dots again, choosing one slit or the other. It was as though the universe kept multiple possibilities open and only settled on one, when an observation was made. But here's the deeply unsettling part. If the mere act of observation changes the outcome, what else might our awareness be shaping without us realizing it? How much of reality exists independently of us, and how much exists because of us? For a long time, some physicists tried to escape the strangeness. They proposed that perhaps there were hidden variables, some invisible factors guiding the particle's behavior behind the scenes. That way, the particle's path would always have been determined, and observation wasn't truly influencing anything. But decades of ever more precise tests, especially those designed to break what's known as Bell's inequality, left no doubt. Hidden variables don't explain the results. The universe really does appear to operate according to rules that defy classical intuition. A particle may genuinely exist in multiple potential states, and somehow, our decision to measure, even from across vast distances, determines which one becomes real. That's not science fiction. That's verified quantum behavior. And if you feel a chill of unease, that's not a bad thing. It means you're beginning to sense just how heavy this mystery really is. The implications ripple far beyond the laboratory. They reach into questions we usually avoid asking. The old philosophical puzzle asks, if a tree falls in a forest and no one is around to hear it, does it make a sound? Quantum mechanics pushes the question even further. If there's no observation, does the tree fall at all? Or does it remain in a suspended state, like the covered objects in that room, waiting for someone to pull away the veil and give it definite form? Suddenly, our role in the cosmos feels less like passive bystander and more like active co-author. Not because we want it to be this way, but because the mathematics and the experiments insist on it. Reality doesn't seem to finalize without an observer stepping in. Now, to be clear, this doesn't mean that everything is just in your mind, or that you can magically conjure riches or objects out of thin air. That's not what quantum mechanics says. But it does suggest something profound, that your experience of the universe is entangled with the act of perceiving it. That your consciousness, whatever it truly is deeply woven into the machinery of existence at its most fundamental level. Matter and energy are not enough. There is something else. Awareness, choice, interaction, that appears to be stitched into the very framework of reality. Ancient wisdom traditions long spoke of existence as illusion, Maya, a dreamlike veil draped over the real. Back then, it was dismissed as metaphor or spirituality. But now, thousands of years later, physics is whispering something uncannily similar in a completely different vocabulary. The illusion isn't that nothing is real. The illusion is believing that the small slice we perceive is the whole. What we call real may be just one frozen frame of an endlessly fluid field of possibility. And that frozen frame seems to crystallize only when observation touches it. Think about that. You don't merely live in a world. In some mysterious way, you help carve the world into shape. Every glance, every question, every act of noticing participates in bringing out you, ohms into being. It's tempting to believe quantum behavior is just a strange sideshow. A circus act tucked away in laboratories where scientists shoot single particles through high-tech machines. Maybe it feels safe to think that way, that the weirdness lives over there, in a realm too small to matter for everyday life. But the unsettling truth is this: the rules of the quantum world govern everything, everywhere, all the time. They don't just apply to tiny particles. They apply to you, to this screen, to the light entering your eyes right now, and to the neurons firing in your brain as you process these words. Quantum mechanics isn't a hidden basement beneath reality. It is reality. What unsettles us is how different this reality is from our expectations. Our minds evolved to see the world as solid, consistent, and dependable, because that's what helps us survive. But at the base of all things, solidity is an illusion. Even the ground beneath your feet is a restless field of activity, an ocean of vibrating possibilities stabilized only through interactions and observation. The rock that feels firm is mostly empty space. The atoms composing it are mostly probability. Reality's apparent stability is a miracle of constant measurement, a ceaseless dance where possibility collapses into presence again and again. And the deeper we look, the stranger it becomes. Take entanglement. When two particles are born together, their states remain linked no matter how far apart they travel. Measure one, and the other instantly reflects the result, even if it's across the galaxy. Einstein famously mocked this as spooky action at a distance, because it seemed to violate the speed limit of light itself. How could one particle communicate with another faster than any signal could travel? But over and over, experiments prove the same thing. The entangled pair doesn't behave like two separate objects at all. They are parts of one system, one whole, stretching across space. What you reveal in one is already mirrored in the other. This is more than a curiosity. It shakes our understanding of space, time, and separateness itself. If entangled particles remain connected instantly, even across cosmic distances, then maybe distance isn't what we thought. Maybe space and time are not the most fundamental features of the universe. Maybe they are emergent properties, secondary effects arising from something deeper. Some physicists now suggest that space and time themselves may emerge from networks of quantum entanglement. In this view, the fabric of reality isn't woven from matter at all. It's woven from relationships, from connections, from information. Pause on that thought. If reality emerges from entanglement, then you are not an isolated spectator drifting through a cold, indifferent void. You are a thread in a web of interconnection, stitched into the cosmos by bonds that extend beyond ordinary space and time. The idea that you are separate, self-contained, and fundamentally alone may itself be the illusion. But this leads to an even thornier question, one that physicists still wrestle with. What exactly is an observer? When quantum theory says that observation collapses possibilities into actualities, what counts as observation? Does it require a conscious mind? Or is any interaction, say a detector clicking in a lab, enough? In some interpretations, the universe doesn't care whether a human is watching. It just needs an interaction, some exchange of information. But others argue that consciousness cannot be ignored, that awareness itself plays a special role. And here lies the core of the debate. If consciousness is necessary for collapse, then awareness is not just a byproduct of matter, but an active force shaping it. That would flip our worldview upside down. Instead of mind arising from matter, matter would, in some sense, require mind. Instead of consciousness being a fragile spark in a vast machine, the machine itself could depend on consciousness to run. Not every physicist agrees. Some prefer the many worlds interpretation, which says collapse never happens. Instead, every possibility splits off into its own branch of reality. In one world, the particle goes left. In another, it goes right. In one world, you made that phone call. In another, you didn't. Each timeline continues, parallel and unaware of the others. A vast multiverse of possibilities where everything that can happen does happen. In this view, observation doesn't create reality. It just determines which branch you find yourself traveling down. Others argue for a different picture, that the wave function, the math that describes probabilities, is not a physical thing at all. It's simply a tool for predicting outcomes. In this case, collapse is not a real event, just a shift in our knowledge when we make a measurement. Reality was always definite. We just didn't know it. The problem? None of these interpretations can be proven right or wrong. All of them match the equations. All of them predict the same outcomes in experiments. Quantum mechanics works flawlessly in practice, explaining why atoms hold together, why the sun burns, why electronics function. It powers technologies we rely on every day: lasers, MRI machines, GPS, the chips in your phone. And yet, when it comes to the question of what it all means, what's really happening underneath the math, the theory leaves us in the dark. This is why some scientists hesitate to talk about it, because the implications don't just rewrite physics textbooks. They touch on existence itself. They tug at the foundations of philosophy, of consciousness, even of spirituality. They force us to ask whether the universe is a machine grinding forward on its own, or a conversation between awareness, S, and matter. And here's the remarkable thing. The math doesn't let us ignore the question. Quantum mechanics isn't just a set of equations. It's a mirror. It reflects back at us the limits of our understanding, the strangeness of being, the role of perception in shaping what is. It invites us to reconsider everything we thought we knew about the line between out there and in here. Because what if that line doesn't exist? What if the world isn't divided into external reality and internal observer, but is instead one single, indivisible process? A process in which looking and being looked at, observing and existing, are inseparably entwined. That's the haunting possibility quantum physics leaves us with. Not that the world is an illusion in the sense of being fake, but that reality is participatory. That without observers, it remains a haze of potential. That with observers, it crystallizes into the reality we know. And so the question grows heavier. If awareness helps sculpt reality, then what is awareness? Where does it come from? And how much power does it truly hold? The question of the observer isn't just technical, it's personal. Because hidden inside this riddle is a reflection of you, me, and every conscious being. If reality refuses to finalize without observation, then awareness is no longer a side effect of matter. It becomes part of the blueprint. Think about your daily life. You look around and assume the world is simply there, waiting for you. The sun rises, the chair sits in the corner, the glass holds water. But what quantum theory suggests is far stranger. It says those objects don't carry definite states until they are observed. They are possibilities waiting for attention. A chair isn't a chair until interaction pins it down. The glass doesn't contain water until measurement collapses the wave function into that form. Reality is not a ready mulm, a film playing on a screen. It is a script with countless endings, and your observation chooses which line is delivered. Of course, we need to be careful. Quantum mechanics doesn't say you can manifest whatever you imagine by sheer thought. That's a distortion. But it does say that awareness and measurement are woven into the process of reality itself. You are not separate from the cosmos looking at it from the outside. You are entangled with it, participating in its becoming. And the more deeply scientists probe, the less room there is to hide from this conclusion. Quantum experiments keep pressing the same point. Reality is not what it seems. Take Schrödinger's cat, a thought experiment so famous it's become cliché, yet still shocking when you really sit with it. A cat is placed in a box with a mechanism tied to a quantum event. Say, the decay of an atom. If the atom decays, poison is released and the cat dies. If not, the cat lives. According to classical logic, the cat must be either alive or dead. But according to quantum mechanics, until observed, the system exists in superposition. The atom has both decayed and not decayed. The poison has both been released and not released. The cat is both alive and dead. Only when the box is opened, when observation takes place, does one outcome collapse into reality. This isn't just a weird puzzle. It's a metaphor for the entire universe. Before observation, existence holds countless possibilities. After observation, one outcome becomes real, which means that in some mysterious sense, the act of noticing doesn't just report reality, it chooses it. But how far does this extend? Does it apply only in controlled labs, or is it happening everywhere, all the time? If every atom is governed by these rules, then every object, every event, every part of your life is too. The collapse of probabilities isn't rare. It is constant, woven into the heartbeat of existence. Some physicists try to soften the strangeness. They say, "Don't worry, macroscopics. Objects are different." Decoherence makes the quantum haze vanish at large scales. And they're partly right. Interactions between countless particles blur the weirdness into the stable reality we experience. But decoherence doesn't explain the collapse itself. It doesn't remove the observer. It only hides the mystery behind layers of complexity. Beneath those layers, the same puzzle waits. This is why quantum physics has become more than science. It has become philosophy with equations. It forces us to stare into questions we normally ignore. What is real? What does it mean to observe? Why does awareness matter? And once you let those questions in, they don't go away. They start to echo through your thoughts, through your sense of self, through how you see your own life. Because if observation and reality are bound together, then your choices of where to place attention, of what to notice, of how to focus, are not trivial. They are acts of participation in the unfolding of the world. Consider this. You've probably experienced moments where your perception shifted reality. A conversation where your interpretation of a single word changed the meaning entirely. A situation where your focus on danger made the whole world seem threatening. Or a moment where gratitude made everything glow with possibility. These are not quantum experiments in a lab, but they echo the same principle. Observation changes what is. Attention collapses potential into experience. Quantum physics tells us that at the foundation of the universe, possibility rules. But your own life tells you the same thing on a human scale. The way you observe shapes what you encounter. The way you interpret sculpts what you believe. The act of noticing is not passive, it is creative. This isn't magic, it's mechanics. Not mechanics of levers and gears, but of perception and collapse, of wave functions and choice. Reality doesn't pre-exist fully formed. It waits. And you, through awareness, help decide how it shows up. And here's the breathtaking part. We don't yet know the limits. We don't know whether consciousness is fundamental, or emergent, or something beyond our categories altogether. We don't know how deeply awareness shapes matter, or whether the universe itself is in some way conscious. These are frontiers where science blurs into philosophy, where experiment meets wonder. But what is clear is this. The old picture of reality as a fixed, solid, objective machine is gone. The quantum revolution shattered it. In its place stands a picture that is stranger, subtler, and infinitely more participatory. A picture in which you are not a passive observer drifting through a pre-written script, but a collaborator in the writing. And once you glimpse that, you can never see life the same way again. At the core of quantum theory lies one principle that refuses to let us rest: uncertainty. Heisenberg's uncertainty principle states that certain pairs of properties, like position and momentum, cannot both be known precisely at the same time. The more accurately you pin down one, the less clearly the other can be defined. This isn't just a limitation of our instruments. It's not because our microscopes aren't sharp enough or our detectors not sensitive enough. It's built into reality itself. The electron doesn't hide its exact position while keeping its momentum secret. Instead, it literally does not possess both values at once. The very notion of a fully knowable, fully determined world is shattered. Uncertainty is not an error, it is a law. Think about what that really means. For centuries, the dream of science was to map the universe completely, to know the clockwork of reality so perfectly that, given the starting conditions, the entire future could be calculated. Determinism was the creed. If you knew all the forces and all the positions, you could predict everything. The rise of Quao-E until mechanics destroyed that dream. The future is not written in advance. The fabric of reality is probabilistic. When you measure, you don't reveal what was already there. You trigger one possibility out of many. Which outcome? The universe doesn't say until the observation happens. In other words, the world is not a script to be read. It's a dice game that waits for you to roll. And this randomness is not confined to physics labs. It is the same randomness that gave rise to stars, to galaxies, to life itself. Every structure, every organism, every mind is the result of collapses, of probabilities resolving into outcomes, one after another, across billions of years. You are here because reality has been rolling its quantum dice since the beginning. But randomness alone is not the whole story. Within the probabilities lie patterns, symmetries, laws. The dice don't fall without rules. They fall within a framework that makes the universe both unpredictable and ordered at once. This strange marriage of chance and law is what gives rise to complexity, to novelty, to emergence. Without uncertainty, the universe would be a frozen machine. With too much chaos, it would be noise without structure. But quantum mechanics balances both, and from that balance arises a cosmos that is alive with possibility. Now, if you step back, something striking appears. The uncertainty principle doesn't just apply to particles. It feels like a metaphor for existence itself. In your life, the more tightly you try to predict every outcome, the more you discover things slipping beyond your grasp. The tighter you hold control, the less room there is for possibility. And yet, without uncertainty, there would be no freedom, no creativity, no evolution. Just as in physics, uncertainty is not a flaw in life, it is what makes life possible. This is why quantum theory resonates so deeply, far beyond equations. It whispers something about the human condition, that certainty is an illusion, that the future is open, that possibilities are real until choices are made. But quantum mechanics doesn't stop at uncertainty. It forces us to face even stranger truths. Truths that suggest reality itself may be an emergent phenomenon. Some modern interpretations propose that information, not matter, is the bedrock of existence. That at the most fundamental level, the universe is not made of particles or fields, but of bits. Yes, no, one, presence, absence. In this picture, everything we see, stars, atoms, minds, emerges from patterns of information. The collapse of a wave function isn't just a particle choosing a path. It's information being updated, the universe registering a new fact. If this is true, then awareness may not be a latecomer to the cosmos. It may be entwined with information itself. After all, what is consciousness if not the experience of information from the inside? When you observe, you don't just take in data, you experience it. Perhaps the universe requires that experience, in some form, to be complete. This is where physics, philosophy, and spirituality begin to blur. Some scientists recoil at the suggestion, fearing it slides into mysticism. Others embrace it, pointing out that the data leaves us no choice but to reconsider the role of the observer. The collapse of possibilities into reality cannot be described without involving observation. And whether that word means measurement, interaction, or awareness, the fact remains. Without it, the universe doesn't finalize. And so we circle back to the haunting possibility that consciousness is not just an emergent property of matter, but an ingredient of existence. That matter needs mind as much as mind needs matter. That reality is incomplete without awareness. If this unsettles you, you're not alone. Physicists themselves confess to unease. Feynman once said, "I think I can safely say that nobody understands quantum mechanics. Not because the math is wrong, it works perfectly, but because the implications tear at the fabric of how we think the world must be." Yet here we are, living in a universe where particles can be entangled across galaxies, where outcomes don't exist until measured, where uncertainty is law, and where awareness may be woven into the heart of reality. And if that's true, then every moment of observation is not trivial. Every act of noticing, every spark of awareness, is not a flicker in a void. It is part of the very mechanism by which the world becomes real. Stand back far enough, and the whole mystery shifts scale. What began as subatomic strangeness becomes a cosmic riddle. If quantum mechanics governs everything, then the rules of uncertainty, entanglement, and observation don't stop at electrons. They stretch across stars, galaxies, even the birth of the universe itself. Cosmologists now ask, did the cosmos need an observer from the very beginning? In the earliest moments after the Big Bang, reality existed as a wild superposition, a sea of quantum fluctuations. From that haze emerged particles, forces, and eventually the stars and galaxies we see today. But what triggered those fluctuations to become definite? Did the universe collapse its own wave function? Or did it require observation to solidify into the world we know? Some theories propose that the universe observes itself, that interactions between particles act as constant measurements. Others suggest that consciousness, however primitive, however diffuse, was present from the start. If so, awareness may not be an accidental spark billions of years later on a small blue planet. It may be one of the roots from which the universe grows. And if that is true, then our role as observers takes on staggering weight. We are not passive products of a mechanical cosmos. We are participants in a living, self-aware process. When you open your eyes, when you notice tingals, e-world, when you reflect on your own thoughts, you are engaging in the same act that has shaped reality since the dawn of time. Collapsing possibility into actuality. This is not a call to abandon science for fantasy. It is the opposite. The equations themselves, the experiments themselves, force us here. Reality is not independent of observation. The observer matters, and you, as an observer, matter more than you realize. Think of your life. Every choice, every act of attention is like a measurement. When you decide to look for beauty, you collapse the haze of indifference into moments of wonder. When you focus on fear, you collapse possibilities into outcomes that confirm danger. Just as in the lab, the act of noticing shapes what becomes real for you. The quantum field may hold endless potentials, but your observation selects which ones solidify into your lived experience. This is why perception is powerful. It is not just a lens, it is a creative act. Every day, you co-author your reality with the universe. The way you look determines what you see. The way you see determines how the world becomes for you. And the deeper implication is this: maybe the boundary between physics and life, between science and spirit, is thinner than we thought. Quantum mechanics doesn't hand us easy answers, but it does invite us to ask bigger questions. Not just about atoms and equations, but about ourselves. About why awareness exists at all. About why anything exists at all. So where does this leave us? With humility, yes. Because the universe is stranger than we can fully grasp. But also with empowerment. Because the mystery of observation reminds us that we are not irrelevant specks drifting in a vast, indifferent void. We are part of the process by which reality comes into being. Einstein once wrote, "Reality is merely an illusion, albeit a very persistent one." He may not have meant it literally, but quantum physics suggests he was closer to the truth than even he suspected. The solidity of the world is persistent, but beneath it lies possibility. And possibility waits for observation to crystallize into the real. You, right now, are an observer. That means you are not separate from the mystery. You are inside it, inseparable from it, participating in it. Every glance, every thought, every choice is part of the universe becoming itself. And that is the deepest gift of quantum mechanics. It doesn't just tell us how particles behave. It whispers something profound about who we are. That we are not just in the universe, we are of it. We are not just watching reality, we are helping write it. So the next time you open your eyes, remember, the world you see is not a finished picture. It is a field of potential, waiting for observation, waiting for you.